Start.
Hi everyone, I'm Jyoti Polishetty and we are Group 7. So, this presentation is about bike sharing demand, which is a data set from Kaggle, and we did some data analysis on this data set. So, today our agenda will be like introduction to the data set and what we will be doing, and how we did data loading, data cleaning, and aggregation, and also correlation between the features in the data set and data modeling and the applications and insights of this data set. So, coming to the introduction, basically this data set is we what we are doing here is analyzing bike rental data to identify trends and forecast future demand. So, it's one of a important challenge in the world of urban mobility, that is predicting bike rental demand in a bike sharing system. As the cities continue to grow, shared mobility services like bike sharing play a vital role in promoting sustainable transportation. However, ensuring these systems can meet user demand efficiently, and it is not a small task. And in this presentation we have done data analysis through which we can answer how do environmental factors like weather and temperature can impact bike usage, and also what temporal trends such as time of day or season can affect this rental patterns, and most importantly, how can we use this data to predict future demand accurately. So, and for this, we have used Python, Pandas, NumPy for the data analysis, and we did this using Jupyter Notebook for interactive analysis. And coming to the data sets, we have taken two data sets. One is trained data set and test data set. So basically, the training data set contains rows and columns which explains unique characteristic of this bike rentals. Some main key features include date time, which represents the timestamp of each rental record, and season such as uh, it is taken in winter, spring, summer, or fall, and also holiday and a working day, like if the rental bike is taken on a holiday or working day, and weather conditions like clear skies, mist, or rain, along with the environmental matrix such as temperature, humidity, and wind speed. And lastly, we have rental counts broken into casual users, registered users, and also total count, which is our target variable for the prediction. And same the test data set, we have different rows and columns mirroring the training data structure, but excludes rental counts. And this is where our predictive model will come into play, forecasting the rental counts based on the patterns we identify. And next slide will be explained by Dinesh.
Hello guys. Now I would like to discuss about project overview. Here it divided into four different parts like data collection, data pre-processing, model training, and model evaluation. Simply, we can say that data collection is like splitting the data, like we will train and test the data, and it yeah, it actually says about the details of the training and testing data sets. And while it's coming to data pre-processing, it has mainly three main functions like future determination, feature scaling, and outlier removal, like which is actually like conversion and handling inconsistencies. And while talking about model learning, it actually goes into regression model selection, model learning, and hyperparameter tuning, etc. Like what we can say is we have to predict the data here. And in model evaluation, it mainly deals with root mean square error, which is R square. Next slide. Here we can see the data preparation and data cleaning process. Here is the code, and Firstly, we'll take a data set, and then we can start we start cleaning the data. The objective of this project was it's to ensure data accuracy, consistency, and readiness for analysis. The steps we followed for this project was finding the missing values, which are verified none exist in both data sets, what kind of data types we are having, and we are finding the duplicates and outliers of the data, and date time transformation. And the key outcome for this project was clean structured data aligned across train and test data sets. Next slide. In data aggregation, it mainly consists of four things like analyzed hourly trends, seasonal analysis, working versus non-working days, and importance, which is operational efficiency. In analyzed hourly trends, we identified the peak rental periods during morning and evening in the commute hours, and the importance, which is operational efficiency. Here we can say that uh, we're having a productive predictive modeling, such as features like hour, weekday, and month improve forecasting accuracy and customer behavior, which is very much important for us, like Tyler offering for commuters versus lease riders based on temporal trends. And the next slide will be continued by my friend Manikanta.
Coming to hourly trends, the data shows two peaks. One in the morning between 7 a.m. and 9 a.m., and another in evening between 5 to 7 p.m. This matches typical communication hours. Rentals were lowest between midnight and 5 a.m. Coming to daily trends, rental remains steady morning through Friday, with slight increase on Thursdays and Fridays. However, we saw a drop during the weekends, especially on Sundays. This suggests weekday rentals are more commuter driven. Coming to monthly trends, we observe rising trends from January to June, peaking during summer months like June, July. Demand gradually declined from September onwards, reaching a low in December due to cold weather. Almost like friend will continue.
And coming to the weather condition during the rentals, so here, so we are displaying we're displaying the correlation heat map. So we used a correlation heat map to identify the relationship between numerical features, and features like temperature had a strong positive correlation with the rental count, while humidity had a negative correlation here. And so these helped us to select important features and avoid multicollinearity. And here what we found the sense, so here we found the clear weather in the type 1, like highest average rentals indicating the ideal biking conditions. And the second one will be cloudy conditions, so it has a moderate rentals and then showing weather conditions like slightly affecting demand. In rainy in rainy type, it will be notice drop in rentals and suggesting average conditions. And in heavy rain, it will be like lowest rentals and extreme weather as a dead end. And next slide. And here, uh, so by explaining these relationships, we could focus on features so that truly impact on demand. So it also help us to improve model interpretability and simplify the selection of input features. And here, it figures the installation. It creates a canvas for the heat map with the defined dimensions for a better visualization. And here the heat map plotting will be defined as it will visualize the matrix with the values annotated to the plot for clarity. And for the next slide. And coming to the correlation heat map. So here our goal was to build a model to forecast rental demand. So we tried various regression models including linear regression, decision tree, random forest, and gradient boosting. So the random forest regressor performed the best with an RMSLE of 0.329. So here the feature selections will be the highlights which features strongly influence the target, such as temperature and humidity, and the multiconarity. So it identifies the features may overlap in information such as temperature and a temperature to simplify the model. And coming to the model insights, so it guides the pre-processing and improves the interpretability of machine learning results.
So, hello everyone. Apart from the data analysis part, we also extended our project by implementing some machine learning algorithm. So, this is the predictive model we have used in here. So, first of all, we imported the necessary libraries which were used in this project. First, we imported the test and train test and split from the sklearn model selection for the splitting of data, and for the random forest regressor, we imported from the ensemble library, and we imported the mean squared log error for this sklearn matrix for the evaluation. So on the for next step, we go for the convert data time to data time objects. So we use the pd.datatime function in pandas. It's converted the data time columns from a string format to the data time object. It enables advanced time-based operations. So as we see in here, we use the train data and data time and test data, two types of data sets, and we use the function to train this to create a different separate columns. And we use that extract data frame features. We use the same columns, and we use the separated data like for the hours, for the weekends, for the months, and for the years. For that, like that, we have done for the both training and the testing data. And next, we drop the unnecessary columns which were unnecessary for this project. We drop the data time, casual, registered, and count columns which were not needed for this project. And next, we insert the test data as also at the same feature set. Like we use the drop same function. We drop the data time column from the text data set also. Next slide. So predictive modeling. So predictive modeling is our main objective was to develop a model to predict bike rentals demand based on historical data. So libraries for that we use the pandas for the pre-processing and matplot for the visualization, and for the feature engineering extracted key data mine features like hour, weekends, months, and years to enhance the model insights. And we splitted the data into the training data and testing data for the robust model evaluations. And the model selection, we have tested multiple regression models like linear regression, decision tree, random forest, gradient boosting to identify the best performing algorithm. So out of them, we use the random forest. So which is the combination of multiple decision trees. So we use for that, and its best model was the random forest regression, so which has the low RMSLE of 0.329 for reliable predictions. So outcome was the model effectively captured the patterns in rental demand, ensures accurate and actionable forecasts. Next slide. So for the random forest algorithm implementation, we train the data into the splitted the data into training data set and the testing data set in the ratio of 0.7 ratio. And we initialized the model we trained the model of the random forest with like 100 of random trees, and we predicted the data by using the test data set. And here you can see the validation RMSLE score of 0.329. So RMSLE is a robust metric for data sets with large differences in values and penalizing underestimates more than overestimations. So that split ensures fair validation by testing the model or on unseen data. So the next slide will be presented by my friend.
Yeah, coming to the applications and insights, we can categorize mainly into the operational benefits, strategic impacts, and future applications. So, coming to the operational benefits, identify the high demand hours for better resource allocation and plan maintenance and bike redistribution during the low demand periods. So, and enhance customer satisfaction with the availability during peak hours and inform marketing campaigns targeting the specific weather or seasonal conditions. And coming to the future applications, we can extend this model insights to real-time predictions and optimize station level be like bike availability using the granular demand forecast. Next slide, please. And coming to the conclusion, this is the conclusion points for the overall data art project. So, peak rental insights. Morning and evening commute hours see the highest demand with the clear weather and summer months driving significant increases. Seasonal and weather trends. Rentals align with the seasonal patterns, peaking in summer and fall and dropping during winter and adverse weather conditions. Model performance. Random forest regressor provided robust and accurate predictions with the RMSLE score of 0.329, demonstrating its reliability for demand forecasting. And challenges tackled. Address the data imbalances in winter months and optimized feature selection to enhance model accuracy. And the future directions. Aim to integrate real-time data streams for dynamic predictions and explore advanced models like deep learning to capture complex patterns. So, and coming to the final, the operational value and findings enable targeted strategies for resource allocation, scheduling, and meeting user demand effectively. So, thank you, ma'am, for giving us this opportunity. And this is our project. Thank you.
Thank you, ma'am.